My name's Matthew Cutler-Welsh. Those that don't know me, I'm the Education Manager for Pro Clima here in New Zealand, and we're doing a bit of stuff in Australia as well, which is pretty exciting. But I'm relatively new to the scene. We've got Asai presenting today, who's been pretty instrumental in introducing Pro Clima really to New Zealand over more than a decade now. So he's got a lot of technical expertise, and we started presenting in person last year to some installers, and one of the things that we found was that people really enjoyed or wanted to see details, both drawings, but then also examples of those drawings and how they get applied in the real world. And that's what this session is all about. And it's kind of fortuitous in some ways that we're able to do this to such a wide, because there's no way we'd be able to present to such a wide group of people if we had the mindset that we had to do these sessions here in person. So it's great that we have the technology now to present like this. Of course, nothing beats being face to face and getting your hands dirty and getting on the products, which we will be getting back into that sort of training fairly soon. So look forward to that. But these sessions will be very beneficial. Our aim is to have these sessions probably once a fortnight, and we've got a range of topics that we're looking at covering. And they're basically, we're looking at the weather tightness on the outside, and in a series like today, we'll be focusing on the air tightness. And the point of these is to introduce everyone to some of the details that we are now getting available and making available for download via our website, which Sai will introduce you to. But it's also to talk about, just jump into the actual application, because we spend a lot of time in some of our other sessions talking about building physics and the science behind why air tightness is a good thing. This session is not so much about that. It's about how do you actually apply these systems in the real world. So they are, we do want them to be interactive. So please do feel free to ask questions. You should be able to unmute yourselves and speak up if you wish, or feel free to use the chat and ask a question, and then either I can feed it through, or we can do those throughout the session. So I will hand over to you now, Sai, if you want to take it away.
Cool, thank you, Matthew. Yeah, you might have well and truly oversold my position, but I have been working with Pro Clima for 10 years, and it's been one hell of a journey, and there's been a lot of changes in the industry in terms of the types of buildings we're building, and hopefully in the future it's going to get even better. So just a wee bit on myself outside of Pro Clima. I've got some unusual passions in life. One is energy efficiency, and especially passive house. I built my own passive house 3 years ago now, which I'm currently sitting at the moment. I'm fortunate enough to work from that. And as you see in the background, which my colleagues give me a lot of stick about, the pictures on my wall, I'm very passionate about jet boating and jet boat racing. So it's extreme polar opposites in terms of what I'm into. So anyhow, let's get underway. So as Matthew said, the whole point of this is to go through some of the construction details that we have readily available on our website to all of you. It's one thing that we've invested a lot of time, and I dare say money in over the years, is to have the details available for designers and for the trade in terms of understanding where things are located and how they should be installed. So if you get a chance, jump on the website. We've got the 3 sections available at the moment, which covers the roof, the ceiling, and the wall. We will also have internal penetration and external penetration details. We're jumping into windows as our next phase, so we're going to have a range of windows, which will also cover recessed windows as well, which is a hot topic in the market at the moment. And looking into getting into CLT, SIPs, and hopefully straw bale, which is another thing I'm thoroughly into. So jump on there, have a look, make any suggestions that you see that you'd like done maybe, because we do have a swag of details in the pipeline, and feedback's always good in terms of what the market's after. So do let us know if there's anything you'd like us to produce. Fairly simple in terms of the details. They're all numbered, they're all color coded, and like I say, we will be regularly updating these and adding to them as well. So please jump back on the website if you're looking at reusing or wanting new details, because they are being updated on a weekly basis. So Rich, my colleague based in Wellington, he's the main man behind a lot of these details. So yeah, I think there's some new ones come on today. Rich, is that right? Some roof details, like one of the ones that you see in front of me now, which is showing the location of our roof underlays.
All good, site.
Yep, present. Awesome, good as gold. So we talked about myself. So just what we're going to cover today, just a wee bit of a intro to the Pro Clima range, and then we're going to look at the details. So the details that we're focusing on today is the internal to external wall connection, the mid-floor connections, and any questions. As Matthew said, if you do have any questions, we're only a small group. Please either unmute yourself and ask them as we go, or feel free just to upload the question into the chat channel, and I'll either pick it up or Matthew will pick it up. So yeah, in terms of our product offering in New Zealand, we have a range of external weather resistive barriers. So for the wall, we've got a couple of wall underlays, one being our Solitex X Designer, which is a staple-on synthetic non-porous membrane, as well as a fully adhesive-backed product called the Solitex Adhero. Something that's new to us in the last 12 to 18 months, widely used on commercial multi-story constructions, as well as the SIP panel CLT, or any rigid substrate that you want to adhere to. So the Adhero can be used for roof and wall applications. In the roof, we have a range of synthetic membranes from lightweight, medium weight to specialist Euro tray roof underlay products. And for the external wall and roof underlay systems, we've got all the system components, tapes, glues, penetration grommets, and the likes. On the internal, which we are predominantly discussing today, is our humidity variable membrane, being the Intello, which is designed to encapsulate the inside of the building for energy efficiency by retaining heat inside the building, and also to prevent moisture going into the construction from the inside and condensating. As part of that, we've got all the system componentry as well, so the tapes, the grommets, and the glues as well. Just as you'll see along the bottom of my page, there's a few things, processes that we've gone through in terms of brands appraisal, code mark certificate, recently been registered with a sensitive choice through the Asthma Foundation, and also some of our internal products are Passive House certified componentry. Hot off the press this week from Germany is our new spray-on membrane. The Arizona Viscon is now a Passive House component as well, so that'll be coming out in the next newsletter. The two things on the far left-hand side are the Declare and Living Building Challenge and the Red List Free, something that I'm quite passionate about. This basically is an online register for building material manufacturers for products that haven't got any nasty toxic ingredients. So the online library has a register of 777 toxic ingredients that make up a lot of building materials that are used widely in the New Zealand market. Fortunately enough, most of our products have gone through the full Declare process or are Red List free. So if you are designing a living building challenge, or you're just looking for materials that haven't got any nasty toxic ingredients, come and talk to us, because a bulk of ours have gone through that full process. One of the other things on the far right you'll see is we are the Australasian distributor for the Minneapolis blower door, something that we've got a lot of blower door operators nationwide that are doing air tightness tests on Pro Clima jobs, SIPS panel jobs, CLT jobs, or general quality control for draft stopping and what have you. You can jump online if you're wanting to have a blower door test done. We have got a list on our Pro Clima website of all of the blower door operators nationwide, and we're regularly running blower door events, which Matthew holds online and up at Notion in Auckland. So yeah, any questions whilst we're on this page? Perfect, move along. Cool, let's get straight into it. Let's dive into the details. That's what we're here for. Just a few things. There's been some interesting, healthy conversations online about some of the construction details that have been put up. And it's just one thing I just want to go through before we get underway. Firstly, the location of your air tightness and vapor controller, being the Intello, should always be on the warm side of the insulation, so to the inside of the insulation. Secondly, air tightness is always a continuous layer. So it is not something that you want to do in some parts of the building and not others. The whole point of air tightness is to encapsulate the inside of the building to help with heat retention and also the management in terms of restricting moisture or heat flow carrying moisture into the insulation layer from the inside. So when designing air tightness, it always needs to be treated as a continuous layer. Oh, sorry, we've got a bit of an issue here. The other thing is 99% of the products that we supply into the market will have what we call a service cavity. As you see on the construction detail on the right-hand side, we have got the blue dotted line, which is our Intello, and then inside of that, we've got an additional 50 millimeters of insulation. We call it a service cavity because that's the common name for it internationally. What that is there for is not just purely running the electrical and plumbing services. It is also there to have that additional layer of insulation that I talked about, which also is installed horizontally on the inside. Why it's installed horizontally is to help eliminate the thermal bridging through the framework of the building. This is why you have the double up of insulation. So if you look at thermal performance in general, the advantage with having a 90mm stud and a 50mm service cavity versus a straight 140mm stud with direct fixed plasterboard is that double up of insulation preventing their thermal bridging through the frame. So something to consider when detailing an air tightness membrane is to have that service cavity on the inside. The other thing is for obviously the electrical and plumbing services and the ease of the installation of these for the contractor on site. Insulation type and insulation ratios. This is a question that comes up all of the time around, there's a lot of closed cell insulation products available in the market these days. Now the Intello only works with fibrous insulation. When we talk about fibrous insulation, we're talking about glass wall bats like pink bats or Knauf insulation, or wool insulation, hemp insulation, blown-in cellulose insulation. It does not work in front of a closed cell insulation product. So when we're talking about closed cell insulation, we're talking about a product in itself that won't allow moisture to pass through it. So the Intello does not work. The insulation itself works like a vapor barrier. This is where the Intello should always and only ever be used with fibrous insulation. The other thing that's a question that comes up, and as you see on the detail, we have got our main frame with insulation and our service cavity on the inside. General rule of thumb with insulation ratio is 1/3, 2/3. So 2/3 of the insulation behind the Intello and 1/3 of the insulation in front of the Intello. You can have a greater volume of insulation, a greater R value of insulation behind the Intello versus what's on the inside, but that is the general rule of thumb. So most common wall assemblies that we see being drawn is either a 90mm frame and a 45mm service cavity, or a 140mm frame and a 45mm service cavity. We do see a lot of project, or the odd project I should say, come up trying to achieve the passive house standard where they might have a heavier frame like a 190mm and then the service cavity on the inside. But as I say, general rule of thumb, 1/3, 2/3. Engineering is one thing that's been asked around the bracing side of things with some of the details that we're supplying. The details are purely a guide to show where the internal air tightness or external weather tightness layer is installed. There is no consideration in these detailing around the bracing calculation or the engineering of them. So please only use them as a guide to show you where the dotted line being the Intello or the weather tightness layer on the outside.
So that's probably my cue to jump in.
Yeah, go for it. Fire away.
Matthew asked me to join in because of the communication discussion we're having online about the engineering side of things.
Yep.
And there is it's something that should be considered. And just recently we had an issue where somebody was trying to use the wall lining on the inside of your service cavity on the battens as a bracing element.
Mm-hmm.
It can't be done.
It can't. Well, it shouldn't be done.
It can't be done if you want to optimize your thermal
that's correct.
Thermal breaks. Otherwise, because the way that it can be done is basically putting a batten all the way around the frame, which defeats the purpose of the exercise.
Yeah, that's correct. So the discussion point, just so you're all aware, is around using the internal linings as your bracing element, and the fixing of the internal linings on a horizontally installed batten, which is obviously creating our service cavity, and the bracing calculations and what can and can't be done there. So it is a good question, and like I said, it's a very tricky one for us in terms of the whole bracing things. Like, we have seen projects get across the line where they have been signed off with a batten of 45 millimeters on the inside, but we can't be here saying that that's the case for all of them. In regards to the bracing side of things, if anybody is interested, we did have an exercise that we did about 7 years ago where we went through the process with Winstone Wallboard, so the supplier of the Gibbon product, where we did some bracing calculations on a 10 millimeter batten, and that was purely there to reinstate the surface of the framing where the plastic will be screwed and glued back to that substrate, being the 10 mil batten that's directly fixed in through the Intello into the framing. So if anybody wants to know more about that, feel free to send me an email or any of my colleagues, and we can supply that document for you.
No,
go for it.
Brands have done some testing on a 45 mil batten, and I've got that information, or actually it's on my LinkedIn page. I put something up about that with some pictures. But as I say, it means that you're battening all the way around your frame, which defeats the purpose of it. So you might as well go to 140 frame. Also, it just means that if your system is, as you've shown here on the page, then your bracing line needs to be your a rigid air barrier, which obviously would impact on your use of your Intello, wouldn't it?
No, not at all. Not at all. A lot of the projects that we supply the Intello to with that service cavity will use a rigid air barrier on the outside. So whether that be a ply fibre cement, or a rigid air barrier system, or a bracing ply with one of our building wraps or underlays over the top of it, it varies. Yeah, there's so many different options that you can do in regards to that. So. But yeah, if anybody wants to know any more or have any questions around that, just feel free to ask myself or one of my colleagues. So the last thing on this page that just around the detailing as such is, as I say, these are only a guide, and WFI simulations should be considered when detailing any wall makeup, whether it's got air tightness or not, or roof and ceiling makeups. One thing with these details in particular, it is very easy to change the performance or the drying capacity or ability of a wall assembly by simply changing likes the cladding color from a black to a white has a big bearing on the drying capacity of the wall. So if you looked at two extremes, one would be a low pitch white colored roof on the side of Queenstown Hill, to the other would be a steep pitch black roof painting due north on the Canterbury Plains. So you've got big extremes in terms of the drying capacity of the roof or wall makeup, with simple changes to these details, whether it be the external cladding or the cladding color, and also what's being used on the inside for the internal lining. So WFI simulations should always be taken into consideration when detailing wall and roof or ceiling assemblies. Cool. Rightio, let's jump straight into.
So before we move on, there's a couple of questions there coming through about insulation and also MVTR, which I think we'll address some of that later on in another session, Nigel, with regards to RABs and vapor checks. We want to focus more on the air tightness in this particular session, otherwise we're going to run out of time. But a couple of questions just regarding, you mentioned fibrous insulation only. What we're talking about really is insulation that's vapor open. Is that correct?
That's correct. So like if you look at a closed cell EPS, for example, they are virtually vapor tight. So no moisture can move through the product in itself. So that basically makes the Intello somewhat redundant, because you've got a vapor tight layer behind a humidity variable membrane, and the two just don't work together. So fibrous insulation will allow moisture to pass through it, and that's what the Intello is there for, is to control that drying or the moisture loading from the inside, and then the drying of that assembly back towards the inside.
Yeah. And the same would be for PIR. Polo asked about that. So you wouldn't want to mix fibrous with PIR and have the Intello in between.
That's correct. The only situation where you potentially could see that is you're terminating the Intello to the top of an eco block wall or a SIPS panel wall, and that's giving you your continuous air tightness connection, but you're not running it on the inside of PIR. Definitely not.
Yeah. So in general, is it true that you want similar insulation materials either side of that 1/3, 2/3?
That's correct. Yes. Yep. Definitely. So the 1/3, 2/3 is based off the R value. So you're wanting to use a similar product behind and in front of the Intello. You can use different products, obviously, but you just want to make sure you've got the insulation ratio correct.
Yeah. Cool.
Cool. Sweet as. Rightio. First of the detail team is the junction where an internal wall meets an external wall, and we have first up, so we've got a couple of different options here, but let's just focus on this one for the start. So what we're talking about here is a product that we have which is installed at the framing stage, which is our Intello Plus connection strip, which is a 300mm wide strip, and it goes between the end stud of the internal wall where it meets the external wall. So we have our continuous air tightness layer being our Intello, and our connection between the rooms and across the top plate. So this particular product is installed at the framing stage when the framing's being erected, and is stapled off to the end stud. Basically what it does is it allows the main contractor, the main installer of the Intello, to run the Intello across and connect it to the Intello Plus connection strip either side of that internal wall or top plate. So when we're talking about air tightness, we're always talking about a continuous layer. So we need to look at these junctions in particular to give our continuous layer through the walls or through the floors. Couple of photos of this. So this is just a bog standard detail. So here you'll see we've got Intello Plus connection strip glued off to the concrete floor, running up between the junction of the internal and external wall and across our top plate. The photo on the right hand side is post the installation of the Intello, and as you see it's coming across and taping either side of the internal wall to give our continuous air tightness layer through that junction. couple of different ways to do it to increase the thermal performance. The photo on the left-hand side is what we see the super home promoting. So this here, as you'll see, the internal wall is offset from the external wall, allowing for you to run a continuous layer of insulation behind the junction between the internal and external wall and through. So for thermal performance, there's a very, very good way to do it. Now, the main difference between these two details, as you'll see, we kind of see the super home detail has a 90mm frame and a 135mm bottom plate. So at the framing stage, you just need to make sure that there is a small slither of Intello plus connection strip installed where the bottom plate meets the bottom plate of the internal wall, so we can pick up the Intello on either side to give our continuous air tightness connection. The photo on the right, as you'll see, there is obviously I think it's a 140 frame, or it might be a 90mm frame, and the Intello runs continuously past the internal wall and connecting off at the bottom. So this style of construction is generally the way that they build, is they stand up the perimeter walls, put the insulation, put the Intello in, and then stand the internal walls at a later date. Thermally though, both of these details work very, very well. This is similar to what I have in my own house, where the internal wall is offset to allow for that continuous run of insulation across the inside face of the Intello. Wonderful. Any questions just before we move away from the internal to external wall junction? Oh, good, cool. Rightio, mid-floors. So I've got 2 or 3 different mid-floor details to show you, some of which work very, very well with the diagram on the left, which is like a cube on cube, and some work better for when you've got an unusual form where the upper floor might be a different size or different shape to the ground floor. So some work well for one, some work better for the other. So the first one up is our standard what we call a standard platform frame, which is a typical mid-floor detail for New Zealand types of construction. So in this particular detail, what we are showing is the connection from the top plate of the ground floor around the perimeter of the floor joist and back into the inside face of the bottom plate on the first floor. So to achieve that, we have our continuous air tightness layer and our mid-floor connection. To achieve this, we use one of the Pro Clima external membranes. That could be the Solitex Extazana or the Solitex Mento. Now, the reason why we use the external membrane to achieve this connection is because the membrane is going to the outside. Now, as I said in one of the earlier slides, the Intello should always be installed on the warm side of the insulation. Because this is going to the outside, we need to use one of the external products that is very diffusion open, always the term that's thrown around the industry, very breathable. So this allows for easy drying back through the membrane into the cavity outside. Photos of this is a project in Christchurch. So we see on my left, the Solitex Extazana running around from the inside face of the top plate, around the outside of the floor joist, and back in under the bottom plate of the first floor. The photo on my right is showing the connection of the internal wall connection strip to the mid-floor connection. As I showed in a previous slide, it's very, very simple. On a single-story house, your connection strip glues to the concrete floor and runs up the junction between the internal and external wall and across the top plate. Because this is a multi-story building, we need to connect the internal wall connection strip to the mid-floor connection strip. The same would apply at the top plate of the ground floor, would run up between the concrete floor, up the junction between the internal and external wall, and connect off to the underside of the mid-floor connection strip. One other way to do it, which again thermally works a lot better, but is very restrictive in terms of the way that we build houses here in New Zealand, and also with the thickness of our framing material. So as you'll see in this particular detail, the mid-floor connection strips running from the inside face of the top plate round the end of the joist to the inside face of the bottom plate of the upper floor, but it doesn't run all the way to the outside. As you see, there is an additional layer of insulation on the outside face of the boundary joist. What this is doing is just bringing that airtightness connection more towards the inside. So if you are designing or building a house with a thicker stud or thicker framing, this would be a better way of doing that particular detail, what we call a platform frame detail, by not running that strip right the way to the outside. I've done a lot of projects. I've just recently done a project in Christchurch, which is a certified passive house that has done exactly this detail. So just another option. Rightio, balloon framing. So balloon framing tends to work very, very well for prefabrication. So when we talk about balloon framing, we're talking about the frame of the building running all the way up from the ground floor up past the floor junction and right the way to the top plate of the first floor. Why I say this works very, very well for prefabrication is simply you, instead of building your wall assembly horizontally, you build it vertically. The big advantage with this is the continuous run of insulation right the way up the external wall, right from the ground, right the way up to the top plate of the first floor. In terms of the air tightness connection, or through this, it simply runs roughly from the top plate of from the ceiling of the ground floor up to where the bottom plate of the first floor would be. So again, this would be installed at the framing stage. The way this is done is the joists do not run right the way to the outside. So for our engineers that are with us, there's a lot more engineering involved to make this work. Photo of this, so as you see at the bottom here, we've got a ribbon board and the joist will sit on joist hangers on top of this. And we have our Intello running right the way up behind this ribbon board, past the joist, and then through into the first floor. So thermally, this detail works very, very well, and it tends to work even better, obviously, with prefab construction. One way around it is that for traditional stick framing using the pre-frame and nail companies, is to have a higher ground floor wall. So your top plate would run up and stop roughly where your bottom plate is. So you can achieve the same thing with a pre-nail and frame company as you would with an actual prefabricator making the full wall assembly. So just one other thing to consider for designing multi-story buildings. Any questions? All quiet, that's good. My last detail in terms of the mid-floor, which I always said is a bit of a get out of free jail card. The reason why I say this is this particular detail can be done at a later stage. It does not need to be done at the framing stage. So if you've got a contractor that's forgotten to install the mid-floor connection strip detail, this is a way to resolve the issue, to connect the ground floor with the upper floor. So in this case, we've got obviously our continuous air tightness layer, and the connection between the ground floor and the first floor is from connecting the Intello to a continuous row of blocking or a floor joist, gluing to the underside, and the floor joist is then glued to the flooring. So for this, the only thing that is paramount is at the time when the contractor is installing the flooring that it needs to be continuously glued to the floor joists. This is generally done anyway for noise and obviously squeaking of the flooring product, but it is paramount that it is done to be able to allow for this detail to work. So on the long side, you just can simply use a continuous floor joist. Now this does not need to be right on the outside. This could be this next joist in, so you could run the Intello up across the ceiling and connect to this joist. This joist will be connected to the floor, and then you can pick the Intello up or the airtightness connection back over at the perimeter wall by gluing the Intello to the flooring. The advantage with this detail as well is you can install more insulation at the boundary joist or in front of the boundary joist to help with the thermal performance of the building. Make sense? Couple of photos of these. So there's different ways of doing it. This is a project recently been involved with in Christchurch. Perfect situation. The builder did not read the drawings properly and forgot to put the mid-floor connection strip in at the framing stage. So we came up with a solution of exactly this, the through-floor detail. As you can see, they've installed blocking between the joists, which they have glued in, unfortunately not with our glue, but that's fine, to create the connection around the joist to the underside of the flooring. And then in this situation, the Intello will be installed once the insulation's gone in on the inside face of the external wall, and it will glue or tape off along this top plate where this row of blocking has been installed. Fortunately enough, because I was involved in this project, the builder did install a layer of an R1.4 bat between the boundary joist and this row of blocking. So thermally, this particular project will work quite well. Another way of doing this exact detail, if you're into origami, is you can install the Intello around the joist and tape off to the underside of the floor. You still need to make sure at the time that the main contractor is installing the flooring product that it is glued down to the top of the joist. So then obviously you know that you're not going to get any air leakage between the top of the joist and the underside of the floor. This way I would prefer everybody do it because you use copious amounts of tape and it helps with the sales, but it's easier for the contractor to install a row of blocking than it is to spend copious amounts of hours and copious amounts of taping around every single floor joist like we see in the photo. The other way to do it, oh yes.
Yeah, so can I jump in? If you go back one on that photo you're showing now, where the blocks were glued in,
yep.
Is there any way of sealing between the joist and the top plate?
You absolutely can. It's a good question. I'm pleased you raised that issue, Nigel. To be honest with you, I would have installed that row of blocking maybe another 50 mil further out. And then you've got a nice straight run to connect the Intello to. In this situation, you're still going to have to do a little bit of origami around the bottom of the joist to tape it all off. So it would have been easier and faster just to bring this row of blocking, maybe 50 mil, maybe even 100 mil. What that also allows you to be able to do is actually put more insulation between the boundary joist and that row of blocking. So unfortunately, I guided them from the start of this, and then it wasn't until after they installed this that I actually turned back up on site and saw that they had installed that row of blocking there. But yes, I would have recommended to bring that out another 50 to 100 mil, put more insulation in, and give you obviously a cleaner row to connect the Intello off to.
So is that gluing of those blocks surface gluing, or is it gluing between the end grain of the block and the joist?
It potentially could be either, Nigel. It's probably easier to put the blocking in and then glue like it looks like this is they've done here. and glue between the corner of the row of blocking and the underside of the floor and the joists.
Right. So depending on quite a bit of operator expertise to be able to achieve a continuous seal around that, which we're talking about is maybe a 5 to 10 mil bead of some type of mastic.
Yeah, ideally you use the Orcon, and then obviously we know it's solvent free and it's not going to break down, and then there's no issues connecting the Intello to that glue layer as well. But yeah, all good.
Thanks.
The last way of doing that exact detail, and again, this is a relatively new product internationally and in New Zealand, is the Arizona Viscon, which is a spray-on humidity variable air tightness layer. So same as the photo before where they've glued the blocking in. This simply you spray between the joists and that row of blocking with the Arizona Viscon, and then you'd run the Intello up and connect that to that row of Arizona Viscon. So if you are an applicator of the product, or you've got access to the spray equipment to spray the Viscon, it is another option. This would be potentially a lot quicker than using a caulking gun and gluing, but you also have to have the proper equipment to spray the Arizona Viscon to make this work. So just another option. Not a great photo. This is actually a project in the States, I believe, but it is another solution for those hard to access places by using a spray gun and spraying the air tightness layer in around these junctions. The same through floor detail also works very, very well for the connection between, oh, sorry, I've got some formatting issues here. The connection between a timber framed insulated wall with Intello and a warm roof structure. With a warm roof structure, the air tightness and vapor control layer is generally the substrate the warm roof is sitting on. So in this situation, it would be a 17 mil or thicker plywood. So there is the only thing that needs to be done is to make sure that the plywood is a continuous layer by gluing or taping the sheets together, and then the Intello would run up the inside face of the external wall and connect, as we discussed before, to the underside of the floor joist, and the floor joist would be, the rafter, in this situation, would be connected to the substrate that the warm roof is sitting on. The reason being the Intello in this situation does not run on the underside of the warm roof structure is because, one, generally there's no insulation on the underside, and two, the dew point in a warm roof is on the outside. It is not on the underside. Please be aware, if designing warm roofs in general, they do not work with bulk insulation on the inside. By putting bulk insulation on the inside of a warm roof, you're potentially moving the dew point to the underside of the substrate that the warm roof is sitting on. Saying that, you can have insulation on the inside of a warm roof, but you just want to make sure that you get the ratios right, and to do that, you can obviously run a WFI simulation. Same with insulation on the inside of a warm roof structure. The reason why you do that is for acoustics between rooms. But similar to the rule of thumb with the Intello, you just want to make sure that you're not moving the dew point to the underside of the warm roof, so it is advisable to run a WFI simulation. Rightio, just a quick wrap up from me. Always like to put this at the end of my presentations. Buildings have to breathe. It's something that's thrown around in the industry a lot. Buildings have to dry, people have to breathe. You can't control what you can't contain. You can't manage what you can't measure. And my favorite of all, build tight and ventilate right. Before I open the floor to questions, just to preempt things for the next meeting, dive into details presentation on the 25th of June, we will be looking at various ceiling or wall to ceiling connections and ceiling details in general. Just a little bit of a sneak peek, this is a photo and a detail what I used in my own passive house, and it's something that we see coming up time and time again. Not allowing for the running of the ducting for the mechanical ventilation system. So some of these details, a lot of these details really need to be taken into consideration when designing low energy or passive house, because there's a lot of things going on with ventilation and thermal bridging and recessed windows and what have you. So do sign up for that presentation on the 25th of June. I'm not too sure if I'm doing it or not, but there's some interesting details. Right, has anybody got any questions?